This is PreCalc 11, Chapter 6.2. This time we're going to be looking at angles in standard position in all quadrants. And because of reflections, there's symmetry in the trig ratios. Here we have theta in the first quadrant, and the reference angle is the same as theta. So that's pretty simple. In the second quadrant, if we have theta here, the reference angle is this angle because the y values match and the x value is reflected. So this is 180 degrees minus theta. If we look at the angle in the third quadrant, this is reflected on the x and reflected on the y. So we get the same y value, but it's reflected. We get the same x value and it's reflected. So this one is theta minus 180 degrees. And finally, if we have this angle in the fourth quadrant, it's just reflected on the x-axis. So theta prime, the reference angle, is 360 degrees minus theta. Okay, we've looked at converting two reference angles. We also need to have the conversion back to standard angles. So in quadrant 1, theta equals theta prime. In quadrant 2, we have 180 degrees minus theta prime, the reference angle. And in quadrant 3, we have 180 degrees plus theta prime. And in the fourth quadrant, we have 360 degrees minus theta prime. Okay, you should compare these to converting to the reference angle. We see that this is the same in quadrant 1. In quadrant 2, it's the same. In quadrant 3, it's different. In quadrant 4, it's the same. So the only one you have to remember that there's a difference is quadrant 3. So let's run through some examples, converting two reference angles. So 300 degrees, that's in quadrant 4. So we do 360 degrees minus 300 degrees, that's 60 degrees. Part B, this one's in quadrant 2, and we have 180 degrees minus 100 degrees equals 80 degrees. 220 degrees, that's in quadrant 3, and we do 220 degrees minus 180 degrees equals 40 degrees. And finally, 70 degrees is in quadrant 1, so it's just 70 degrees. Let's look at converting back to standard angles. And we have to know what quadrant it's in, otherwise there's no way to pick a formula. So quadrant 2 is 180 degrees minus 40 degrees, and we have 140 degrees in the standard angle. 35 degrees in quadrant 4, that's 360 degrees minus 35 degrees, and that's 325 degrees. And in quadrant 1, that's the simplest one, it's just 65 degrees. And 15 degrees in quadrant 3, that means we need to do 180 plus 15, and that's 195 degrees. In the four quadrants, there's positive and negative trig ratios. So, to help us remember which one's positive and which one's negative, we use the mnemonic all students take calculus, ASTC, quadrants 1, 2, 3, 4. So, in the first quadrant, all trig ratios are positive. In the second quadrant, only sine is positive. Cosine and tangent are negative. Quadrant 3, T, tangent is positive. Sine and cosine are negative. And in quadrant 4, cosine is positive. Sine and tangent are negative. So, again, this mnemonic helps state the positive trig ratios. All the other ones are negative. Okay, here's an example. The point -3,7 lies on the terminal arm with theta in the standard position. Determine the primary trig ratios and theta. I'm going to use a scale of 2 for each grid unit. So -3 is here, and 7 is up here. And we draw the line, terminal arm. This is theta. This is theta prime. So x equals -3 and y equals 7. We should calculate the radius, and that's the square root of -3 squared plus 7 squared. And this is square root of 9 plus 49, and that's square root 58. So we look at the mnemonic Sir Kixertix. And sine theta equals y over r, and that equals 7 over root 58. Cosine theta equals x over r, and that equals -3 over root 58. And tangent theta equals y over x, and we have 7 over -3, but we move the negative sign to the top. And now we need to figure out the angle. So we can use any of these and do the inverse operation. Since these are original numbers, it's best to use this one. So theta prime equals the inverse tangent, and we take the absolute value. This is the best way to get the reference angle. And this is approximately, and we check our mode. Need to be in degrees for this problem. And we do second tangent, 7 divided by 3, and that gives us approximately 67 degrees. We know our answer is in quadrant 2, so we need to do 180 degrees minus 67 degrees, and we have 113 degrees. So that's our answer. Now, something that you'll need to know is the principal angle, and that's the coterminal with an angle such that 0 degrees is less than or equal to theta is less than 360 degrees. And one way to find the principal angle is simply add or subtract 360 until it's within this domain. So if we have minus 30 degrees, we would add 360, and we get 330 degrees. If we have 800, that's too big, so we take 800 minus 360, and we get 440 degrees. We need to subtract another 360, and we get 80 degrees. And 200 degrees is simply already the principal angle. And one reason for converting to the principal angle is that it's easy to tell what quadrant the angle is in. And the calculator will produce answers for 2 quadrants, one for the positive, one for the negative, and you need to understand when and how to adjust your solution. And one way is to always take the inverse trig function of the absolute value of the ratio. Anyways, we have determined the principal angle for theta such that sine theta equals -0.6. So theta prime equals inverse sine of 0.6. And this is approximately 37 degrees. So sine is positive in quadrants 1 and 2 and negative in quadrants 3 and 4. This means we need to find two answers, one in quadrant 3 and one in quadrant 4. So theta in quadrant 3 equals 180 plus 37 degrees. And that gives us 217 degrees. And in quadrant 4, theta equals 360 minus 37 degrees. And that's equal to 323 degrees. Here's another problem. Given cos theta equals negative 5 over 13, determine the other primary trig ratios and the principal angles. So we know that x equals negative 5. We know that r equals 13. And the reason for this is r has to be positive, so x must be the negative. We need to find y, so we have y squared equals r squared minus x squared. So y equals plus or minus the square root of 13 squared minus negative 5 squared. So this is plus or minus square root 169 minus 25. This is plus or minus square root 144. So we have plus or minus 12. It's important that you have the plus or minus 12 because we're not told what quadrant it's in. So it's going to be in two quadrants. So Kixer tells us that cos theta equals x over r, and we already know that. Sir is sine theta equals y over r. And we have 12 over 13. However, we also have sine theta equals negative 12 over 13. Ticks. We have tan theta equals y over x. So we have to use the same y here to be consistent. So we have 12 over negative 5, but we put the negative on top. And over here, we have tan theta equals negative 12 over negative 5, so we have 12 over 5. And the reference angle is, we can just use sine inverse of 12 over 13, and that's approximately 67 degrees. Over here, we have theta prime equals inverse sine, and we're going to do the absolute value, so that's 12 over 13, and no surprise, we should have 67 degrees also. We have sine positive, cosine negative. That must mean we're in quadrant 2. So we have theta equals 180 degrees minus 67 degrees, and that's 113 degrees. This time we have sine negative, cos negative, and tan is positive, so that means we're in quadrant 3. So theta equals 180 degrees plus 67 degrees, and that gives us 247 degrees. And if you want to learn how to do all this in radians, watch the radians video. But that completes this lesson.